For this video, we will look at a classic limit problem that I've seen in a few collegiate competitions. The last one I saw goes like this. Find the limit as the x root of the quantity 1 minus 2x as x tends to 0. This particular question was from the 2023 UP Math Club Nationwide Search for the Math Wizard, which is perhaps one of the most, if not the most, prestigious collegiate competitions in the Philippines. Note that simply plugging in x equals 0 wouldn't work because we will be facing with the zeroth root of 1, or equivalently 1 raised to infinity, which is one of the few indeterminate limit forms. So for this problem, I will discuss two solutions. For the first one, we denote the limit as L. Take the natural logarithm of this finite limit, and supposing that the limit exists, we can write the right side as the limit of Ln of the expression. Note that since the x root means something raised to the 1 over x, we can actually simplify the expression by bringing down 1 over x, owing to the power rule of logarithms. Hence, we have the limit of ln 1 minus 2x times 1 over x, or simply ln of 1 minus 2x over x. It seems logical at this point, substituting x equals 0, but we'll see that the limit takes the form ln 1 over 0, or 0 over 0, which again is indeterminate. The good thing is, in this form, unlike the original form, it satisfies the condition for the L'Hopital's rule. We now apply the L'Hopital's, and we take the derivative of the numerator and denominator. The numerator becomes negative 2 over 1 minus 2x, and the denominator becomes 1. Let's try to plug in x equals 0 once more, and we see that it leads to negative 2 over 1, or simply negative 2. Therefore, ln of L approaches negative 2. We're not done yet because we're not interested with ln L, we're interested with L itself. Using the inverse property of logarithms, we get the value of L to be e to the negative 2. Therefore, the limit is e to the negative 2, or 1 over e squared, whichever form makes you happy. And that's the first solution. It's a decent one, but I prefer another. For the second solution, we'll make sure of the limit, or we make use of the limit definition of the Euler number e. Recall that e is equal to the limit of 1 plus u raised to 1 over u as u approaches 0. You might have seen an alternative form of this limit that takes the form 1 plus 1 over h raised to h as h approaches infinity. But we will be working on the definition as shown since it resembles the given limit more closely. The objective is to write the given limit in a form that resembles this definition. We write the expression as 1 minus 2x raised to the 1 over x. The key difference between this and the limit definition of e is that the base is 1 minus 2x instead of 1 plus x. We can sort of fix this by considering negative 2x as a single entity. We then just have to adjust the exponent. The exponent 1 over x is equivalent to negative 2 over negative 2x. Again, we're trying to force our way to the limit definition of e, hence this trick. Now if we let u be negative 2x, we note that as x approaches 0, so does u. As a penultimate step, we use the exponential properties to take out the negative 2 power, leaving as a limit definition of e as the base. Finally, we value the limit using the definition of e. And as expected, the answer is also e to the negative 2. I generally find more elegance in solution 2 over solution 1, but in a time-pressured competition, such as the source of this material, whatever works, works. It's up to you which one to choose. So, this ends the video and thank you for watching. If you haven't subscribed yet, please consider doing so. Until the next one, see ya!